This video is sponsored by Electrical Wingman, your one-stop shop for everything multi-rotor. Check the description box for the link to the website. And also by Tiger Motors. The F series is finally here. Alright guys, welcome to the video. Today we're going to be building the Thug Pig frame. We were given the frame by Stefan from Thug at the drone show, which was in the NEC in the UK. We also spoke to a bloke called Paul from Electrical, who owns Electrical Wingman, who's gave us all of the electronics for to build the frame up. So we've got some Tiger F60s, which aren't out on the market yet. They're for testing, but we sort of thought may as well stick them straight on this. As you can see, there's all the parts which are going to be going in. So we're going to be using 20 amp little B ESCs, 1900 kV F60 motors from Tiger. We've got a Naze 32 Rev 5 which is getting flashed with Boris B. We decided to use a different power distribution board because it was just genuinely easier than having to buy the Palulus. And then we've also got Aonway 200mW VTX, which will be obviously transmitting the video from the craft down to my goggles. In this part we are installing the pins into the Naze 32 flight controller. When you buy the flight controller, there's some companies that offer a service for soldering the pins in, but obviously with me having the mega soldering gun that you can see there, I can do it myself, is not a problem. Just make sure you've got a decent iron, that's all I can really say about that. If you haven't got a decent iron, then obviously pay for the service for them to do it, but if you're a little bit of a dab hand at soldering and you know you can do it and you've got a decent iron, then obviously just solder the flight controller up yourself and save you a couple of quid. So when you're soldering the pins up, all you need to do is just basically slide the pins through the slots on the flight controller and then just solder in one of them, and then you can put it in a little jig to hold it properly then while you solder up the rest. So that's after they've all been soldered. My daughter's doing the usual thing and double checking everything I've done, because that's what she does. She just decides to like smacking stuff after you've been messing with it. So as you can see, all the pins are all soldered in. So we've got the telemetry pins in there. We've also got the output pins going to the motors, and then we've got all the input pins for running PPM or PWM, whichever way you want to go with it. We will be running PWM on this, which is a signal wire for every control. So you'll have one for your elevator, one for your aileron, one for your throttle, your rudder, and then one for your aux 1 and 2. I believe you can run up to 8 channels on this though. Yeah, on the Naze Rev 5 you can run up to 8 channels. So if you've got an 8 channel receiver, then you can obviously set different things on each channel. So you can have like your angle mode and horizon mode, and then if you're running Boris B beta flight, you can run air mode as well, and stuff all off different switches. In this part of the video we are just desoldering the motor wires off the speed controller just to give it a cleaner installation. That's basically the whole point why I'm taking them off. On my ZMR I ended up putting the speed controllers underneath the frame, and obviously you needed a lot more wire, whereas in on the Thug the frame's a nice size to fit the little B20 amps on. So I'm just measuring it up now. So basically you take your ESC out of the heat shrink that it comes with, and then put that down, desolder the wires, and then you can then put it onto the arm and measure your motor wires up. So just put the motor there or thereabouts where it's going to be sitting, measure up to where you've desoldered the wires, and just give it a little snip. And once you've done that, your motor wires are no longer massively enormous, and you can obviously save a little bit of weight then. What you will need to do is you'll need to strip off the ends of the wires and then tin all the wires afterwards, just so it's a lot easier to solder. Ideally when you're soldering stuff you need to pre-tin everything, so then when you put heat on one side it'll obviously heat up the other object that you're soldering to, and it'll stick to it. That's all I'm doing here. just give them a little twist just to make sure that there's no excess wire hanging out or nothing that can short once it's been done. So motor wires are all cut down nice and neat. So now that we've measured up, move the quad out the way and just get hold of the ESC in. Obviously we need to pre-tin the wires as I mentioned. And get out the mega soldering gun. Ideally I shouldn't be using this for doing this job, but it's all I've got and it works, and it gets really hot. A couple of the wires were just a little bit too long, only by like a millimetre, but I'd rather have them all exactly the same length, so we just chop them so they're all the same size. It makes for a cleaner and better installation. So now what you need to do is just line your ESC and your motor back or your motor wires up, and then obviously just heat the motor wire up and keep putting a little bit of pressure on it until it heats the ESC solder up, and then it'll solder straight back on and you're good to go with that one then. Just make sure that when you're soldering the wires back up that you don't put loads of solder on. Now, ideally you want just enough to cover the wires, and then just use the existing solder that's already on the ESC. So it'll give you a nice clean installation and you've got no chance of shorting anything out then. Try not to leave any points on the solder as well, so make sure you do only use a little bit. And if you leave a point on the solder, obviously if you have a crash and your motor's still spinning, then it'll be drawing current through the wiring, and then if it goes through the heat shrink, then obviously it's going to short out on the frame or on something if you've had a massive crash and you managed to snap an arm. Now next up, just measure up the heat shrink just to cover the ESC back up again. Once that's cut to size, you just need to slide that back over your wiring, slide it back down over the ESC. Try your best not to touch the board on the ESC as well. If you're going to manoeuvre it, just use the wires to manoeuvre it, or touch the sides of the board. Don't actually touch the top or the bottom, because you can run a chance of, if you've got a static charge on you, there's a good chance you'll end up blowing a chip. And I know I shouldn't be using a lighter, but it's all I had to hand. I haven't got a heat gun yet. So heat it up and then just pinch the ends of the heat shrink together. Once you've pinched the ends of the heat shrink together, it'll then stop it from getting any dirt or anything inside it. As you can see, I've already done 2 of the ESCs. Well, that's my second one I've just done. The reason why this bit's taking a little bit longer on the video is because what I've decided to do is, when I'm soldering up the ESCs to the motors, or the motors to the ESCs, whichever way you want to say it, I've put one ESC the right way up and soldered the motor wires directly to it, and then I've done that on 2 of them, so that I know they're going to spin one way. And then when I do the other 2, I'll turn the motor upside down so the wiring's the opposite way around, so then I can then solder them motors directly to the ESCs, and then motors should spin the opposite direction, because on a quadcopter obviously you've got to have 2 clockwise and 2 counterclockwise spinning. So I'm just ripping the opposite motor off now, because the other speed controller and motor that I'd done previous to this part of the video, I'd soldered that up in the same way as this one. So because of that, I'll have 2 motors spinning the same way, and then when I do the other 2 in a minute, then I can turn the motors upside down so they spin in the opposite direction. And then at least if we do have any issues where the motors are spinning the wrong way, it's only a case of desoldering the 8 wires off the power distribution board and just swapping the whole motor and ESC over as one thing. So as you can see here, the motor's upside down now, so these are going to be the 2 counterclockwise ones. So as you can see now, the ESC is the opposite way up, so the wiring for the motors is on the bottom. So when I put these onto the arms, obviously I can put the ESC on upside down. It saves me having to twist any wires over, so I know that there's nothing that's going to be too tight, or there's no chance of it tearing a wire because there's too much tension on the wires or anything like that. It's just all 3 wires will just run completely flat and straight. As I said, sorry about the lighter, but it works. I could have used the wife's hairdryer, I suppose, but I didn't really want a bright pink hairdryer on my video. Just stick the little B sticker back on again. Not that you'll be able to see it, because once they're on the arms they're going to have a black tape around them anyway to hold them on, and then possibly even a zip tie depending on how black tape holds up. Now as you can see, we're just installing the motor and ESC, just trying to find a position for all the wiring to go, or for where they're going to be sitting. So as you can see now, they're on the arms. You know, they'll be underneath the props, they'll have plenty of cooling, especially for running 4S. So we've got all 4 done now. The next up is going to be the power distribution board. So this wire that I'm soldering on now, that's the 5V out for the flight controller. Now the power distribution board that I'm using has got a 5V and a 12V BEC pre-built into it, so I can power the flight controller directly from that. I won't need any other voltage regulators or anything. I'm just pre-tinning all the pads on the power distribution board, so it saves me having to do it when it's in the quad, saves any heat transferring into the quad. And just pre-tin the wires. when I pre-tinned the wires, the heat shrink that was already around the wires, well, the silicon decided to shrink just a little bit more, so it left a little bit of excess wire, so just trim that off now. Just put a little bit more solder back on. Now I can just solder this JST plug directly to the power distribution board, and then once everything's in, that'll then provide power to the flight controller as soon as I'm using Opto ESCs. Opto ESCs only have a signal wire and a negative wire on them. They don't provide any power to the flight controller like a linear ESC. As you can see, power distribution board's now got the 2 wires on it, which will provide the 5-volt source to the flight controller. So next up is going to be to pre-tin the rest of the pads on it, which will be for the 4-speed controllers. Battery wires going in as well. So once you've finished doing the power distribution board and you finish pre-tinning everything, that's sort of what it should look like. So you have your motor pads, which should be pre-tinned, your battery connectors, which should be pre-tinned, and your 5-volt source for your flight control. So next up, we will be putting the power distribution board in. Now you put that in on a set of standoffs, which are basically a piece of plastic which screws into the bottom of the frame. Which will then raise the power distribution board up from the frame by around 10mm. Well, around, say, yeah, about 10mm. So you've got no chance of shorting anything out then. What you'll then do is you can route your positive and negative wires, which are for the main power for the ESCs. You can route them and then sort of cut them to size and solder them directly to the power distribution board on the pads for the motor, or for where your ESCs should go. Now at the minute I'm just pre-tinning the wires for the battery connections. I'm using, I think it was 16 or 14 gauge wire for it, so you'll be able to handle quite a high current being drawn through it without getting too hot. So as you can see now, we've now got all the wiring in for the 4-speed controllers and the main battery leads. Our battery leads are quite long. They will be getting cut down when we're soldering the XT60 connector on, which is the type of connector that we'll be using for the main power going from the battery to the power distribution board. So as you can see, we've added a little piece of blue heat shrink just to stop the wires fraying on the frame. If there's any slight vibration or anything, it obviously provides a little bit more protection for things. So I'm just going to take a couple of quick pictures now, just to stick up on Facebook and up on Instagram and all the other social media sites that we're on. Next up is going to be installing the Naze flight controller. So this was the 5-volt source that we took off the power distribution board that we soldered on before. Make sure you don't get the polarity the wrong way around. You need to make sure that negative goes to negative, positive goes to positive, and that's one of the main things that you need to do. When you're putting this onto the flight controller, depending on how many motors and ESCs you're running, if you're doing a quadcopter build like this, then you can plug this into either motor number 5 or motor number 6, which will then power the board. And then obviously the motor outputs from 1 to 4 will be taken up by the speed controllers. And we'll just screw a couple more standoffs on now. As I was saying, the standoffs are basically a spacer which goes in between the flight control, goes in between the power distribution board and the frame, and goes in between the power distribution board and the flight controller. So it lifts everything up out of the way, so it stops things shorting and touching. We've just got 4 of these to screw on. We'll put them on top of the power distribution board, and then we can obviously put the flight controller directly down onto them then. And then they have little nuts that come with them which you can screw the nuts onto, then hold your flight controller in place. Just make sure when you put the standoffs on that you put them on like really tightly by hand. Just get them on as tight as you dare. The last thing you want is to be flying around and they come loose, the next minute your flight controller's hanging outside of your quad. So now we're just putting the ESC wires onto the flight controller. So once you've got them installed, it should look something sort of like that. Now the configuration I've put these on, if I remember rightly, I've put them in wrong. I had to redo them again. Different software, different firmware, i.e. if you're running clean flight and base flight, then they use the same motor configuration, but if you're running something like a CC3D and you've got to use either OpenPilot or LibrePilot, they use a different configuration for where the motors need to go into the flight controller. And these 2 wires that I'm putting in now, these are for the VBAT, which is essentially, it's a battery checker. What it does is it measures the voltage which is in your battery, and then it can then alert you when your battery is flat. You need to solder a positive and negative directly onto where your main power lead's coming from the battery, which it can then measure the voltage from the battery, and it can measure currents and stuff and see how many amps you're drawing and all that good stuff. So next up will be we're installing the 200mW Aeon-Way video transmitter. I've had pretty good luck with these video transmitters, to be honest with you. They're quite a nice small unit, as you can see, so they'll fit into the majority of mini quads. You'll be easy get one into a 200 size frame, or maybe even smaller, like a 160. You should be able to fit one into that as well. Now, I run one of these on my ZMR. I've got fantastic thoughts of it, to be honest with you. I don't really get much in the way of video breakup where we go flying anyway, so going behind trees and stuff, obviously you get a little tiny bit of breakup, but nothing major. I'm just installing some Velcro onto it now, so when we place this middle deck on, we can then push the VTX up to where it needs to be, and it should then hold it in place. Now it's also going to be getting zip tied as well. Velcro, once it goes on, it'll then give us an idea if we ever have to take it back off again, of where it needs to go back, and it'll also provide a good base for it to hold on to, stop it slipping and crashing, things like that. And once we've got the centre deck on, we can then push the VTX up into position where we want it, and then if we do pull it back off again, at least we know where it originally went. Incidentally as well, while I think on, I found out when I put this very same VTX onto my ZMR, the brass connector on the end of it, or the brass SMA connector on the end of it, which is where your antenna would go into, was just touching the frame. So due to that, as I spooled the motors up, it smoked. It didn't cause any damage to it, and I'm still running the very same VTX today. You know, there's nothing up with it, it runs fine, and as you have seen through previous footage of me flying the ZMR. But just make sure that when you install this, that you've got something to insulate the SMA connector on the end of the VTX away from the frame, or just leave it poking out slightly so it's got no chance of touching the frame. As I say, I've put a fair decent size of Velcro on this, so that'll provide the insulation and keep it away from touching the frame. can see it's pretty much solid now, that's not going to go nowhere, so I did end up putting a second zip tie on it. When you install your VTX, make sure that you put an antenna on it straight away. Only for the reason that if you forget to put an antenna on it and you actually plug a LiPo into the quad, there's a good chance you'll blow the arse out the VTX. They are prone for blowing up if you haven't got an antenna on them when you power the quad up. The best thing to do is just get it on and then you haven't got to worry about it. You'll need an 8mm spanner to tighten the majority of them up. And do that, and then you can bend it to whichever direction you want. If you use something like the IB Crazy antennas, you can just heat them up with a heat gun, or dare I say with a lighter, and then you can bend them into shape and just hold it in its position for a short amount of time, and it will then hold that position then that you've placed it into. So next up is going to be installing the receiver. Now the receiver, you've got a different wire for each control input, as we're running PWM on this one, which is pulse width modulation, I think, if I remember rightly anyway. The flight controller can take PPM, which is just a positive and negative in a single wire, not a signal wire, which it will then send all the signals down that one wire, and then the flight controller then works out what you've sent down, and you have to configure all that within clean flight. It's pretty easy to do. It's only a case of changing or changing a tab switch and then just telling it what receiver you're running, and then it'll pick everything up itself. I'm just working out what sort of position that we're going to need to run the receiver in, and where we can place it to keep everything nice and neat and tidy. So now that we've figured out where it's going, we place some Velcro underneath the receiver and a piece on the receiver just to hold it in place. Even though it's wide enough for the top deck to hold it down, you're better off putting a little piece of Velcro on just so it keeps it there, just in case you have any high speed crashes really. That's all, which will no doubt happen to this quad, and it will be getting put through its paces. Well, put through its paces as much as I can put it through, because obviously I've not long started flying, it's only been about 4 months. And now we're just putting the top deck on, just making sure I'm happy with where everything's all situated. So there's 4 little bolts that hold the top deck in place. You just put them in and then job done. Now, as you'll notice, there's no FPV camera in there, and there is a wire hanging out the front ready for it. Unfortunately, at the time of this filming, the camera wasn't here. I've been waiting for a week for it, and I lost my patience and decided to just build the quad and hope that the camera was going to turn up in time, and it didn't. I'll place some pictures at the end of the final finished product, which will also have the camera in it. The camera we were using for this build is a Sony HS1177. I've since found out that Runcam are also doing a camera which they'll recommend for this frame. So we may see if we can get hold of one of them in the near future, but the HS1177 is a brilliant FPV camera anyway. It's cheap, it's reliable, and obviously it works, so that's why I'm running the ZMI, and it's a brilliant camera. It's nice and clear. It's 600 TVL, so it's got a very low latency on it. I just need to go and say a massive thank you to Paul from Electrical Wingman, because without him the build wouldn't have gone ahead. Now obviously he's helped us out with all the electronics, and you know, we've now finally got a really good flying quad, which I've got high hopes for. I need to give out a thank you to Stefan from Thug Frames as well, because obviously he sorted us out with the frame, gave us a bit of discount on it and stuff. So yeah, I'm really looking forward to getting out and flying this now. I say it's got everything in it, all the FPV systems in. Hang on one sec, I'll just spin back around and I can get you a better shot. Is that any better? So we've now got the HS1177 FPV cam in. So looking forward to using that. I've got one in my ZMR, brilliant camera. The battery sits underneath, kind of like so. It's a little bit off centre as you can see, but obviously I'm not flying it in the house, so that really doesn't matter. It will be sorted when it goes flying. We've got Tiger F60s, 1900 kV. So looking forward to shoving 4-cell 3Ds. And yeah, all the electronics are all in, it's all nice and neat. So VTX is in and all in nice and tight and sorted. That really isn't going anywhere. And I need to put a little bit of black tape over the back of the receiver just to stop that from getting damaged if there's any like crappy weather or anything. So, but yeah, that's it. So I really hope you enjoyed the build series, guys. I obviously click the like button if you did like it. If you didn't, then click the dislike button and leave a comment in the bottom and let me know why. And obviously I can rectify that for the next build series, which I think is possibly going to be an Emax 200 frame, which has got some very, very, very special motors going on it, so you might want to keep an eye out for that. Obviously, if you, as I said, if you did like the video, then click the like button and also leave me a comment in the bottom. Let me know what you enjoyed and which parts you enjoyed and all of that lot. And yeah, last but not least, go and check out Paul's site. It's called Electrical Wingman, and as I said, there is a link in the description box which will take you straight through to his site. He's got a lot of good products for quadcopters. He sells tattoo batteries as well. So the tattoo batteries are possibly one of the best you'll get for quadcopters anyway. But yeah, so that's it. So thanks for watching. Click the subscribe button, click the like button, and share the video about. I'll see if we can get some more subscribers in, get Paul to see what he sells and all that good stuff. So yeah, thanks very much guys. Cheers. Bye.